All right, Algebra 2. Today we're moving into 7.6 common logarithms. So for today, we're going to be focusing some energy on how to solve common logarithms, and then we're going to end up being able to convert things like log base 2 of 3, something like this, into a base 10 logarithm. Okay, so that's what we're going to do today so that you can do this kind of thing on any calculator. I've shown a couple people how to do this on a TI before, but if you don't have the option to change your base on your calculator, you're kind of stuck until you learn how to write this as a common log, where I have like the log base 10 of 3 over the log base 10 of 2. Anyway, we'll get all to that by the very end of the lesson. So here we go. Solving exponentials using logarithms. So what you're going to do to solve these exponentials is you're going to end up taking, if you have some, so this is when you have something like, 2 to the y or something like that, and you're trying to solve for that variable that's in the exponential. What you're going to do is you're going to take the log of both sides, isolate the variable, just like Algebra 1, and then we're going to use a calculator to solve the logarithm. Okay, so for example 3, let's go ahead and set this one up. So this is the same thing as, so notice how we have a variable in the exponential piece. This is when you need a logarithm. Okay, so I'm going to take the log of 3x and set that equal to the log of 15. Now when I do this, these logarithms are going to be base 10. We don't put the 10 in there, but it's base 10. So it's like log, so just so you know what's happening here, this is the same thing as like log base 10 of each of these things. Okay, so now that I've taken the logarithm of both sides, now I got to use my properties of exponents and logarithms from last time. So notice that we have something to a power here. So that's multiplication, so I'm going to pull that to the front. This is going to look like this: x times the logarithm of 3 is equal to, and if that is confusing to you, go back to the last lesson and watch the video again. But that is equal to then log 15. And the idea here is that we want to get x by itself, right? So now that this is a multiplication piece, I'm going to divide both sides by log base 10 of 3. So log of 3. And then I get x is equal to whatever that comes out to, and I think I wrote that down just to save some time here. That is equal to 2.4650 approximately. So I'll use the approximate instead of the equal sign. All right, so I trust that you could do this just like I did for 3b, so go ahead and take the shot at that. And here we go, let's work this. So log of 6x is equal to log 15. So pull the x out front, right? X log of 6 is equal to log 15. So then x is equal to log 15 divided by log 6, right? Because we just divide both sides by the log of 6. And then what that comes out to is 2.0860. And again, I should use those guys because we are approximating that thing to the nearest 10,000ths place. Okay, so that's 3a, 3b. They're going to have you do a little bit of that. Actually, in example 1, which I kind of skipped through, they're just going to have you find on your calculator, they're going to have you type in things like, so you can put this in your notes, but you don't really need it. If they give you something like, so 1a, for example, it was log 7. Well, you're just going to use your log base 10 feature on your calculator and then punch in 7. So you could just, if you're on a phone, like an iPhone or something like that, they make you put in this number first. So you would hit the number 7, and then you'd hit the log button, and then that would come out to 0.8451. So you might want to just test that to make sure that you can find that on your calculator, but I didn't have you actually do that for the notes, purposes of the notes. Okay, so example 4, which I want to spend some good time on, is these are inequalities, but the algebra that goes into this is a little bit hectic. Not too bad though, if you guys remember how to use your properties of exponents and logarithms. So here we go. we're gonna do the same thing. We're gonna take the log of both sides. So we have the log of 3 to the 2x is greater than or equal to log of 6 to the x plus 1. Okay, whenever you have this power in here, we got to move it to the front and multiply it out, right? So this is 2x, so I move it out front. Log 3 is greater than or equal to x plus 1, which I'd use in parentheses, log 6. Okay, now I got to distribute. If you have two pieces in here, you have to distribute that. That's the big keys, the big key to this problem here that people tend to forget. Don't forget to distribute. So this becomes 2x log 3 is greater than or equal to x log 6 plus 1, which I'll just write as, I won't include the 1, but log 6. Okay, we're trying to isolate the variable here. So we have an x in this term, we have an x in this term. Let's get all the x's to one side. That is a big takeaway. Get all the x's to one side. So now I have 2x log 3, and I'm going to subtract x log 6 from both sides. So just move that whole term over. So I have 2x log 3 minus x log 6 is greater than or equal to log 6. Okay, now I have x's in both of these pieces here. So I have two pieces there, and I have an x in both. So this kind of goes back to factoring. What I'm going to do is I'm going to take an x out, and what I'm left with is 2 log base 10 of 3 minus log base 10 of 6 is greater than or equal to log 6. So we're going to continue this over here. Okay, so to get x by itself, I'm going to have to now divide both of these by this thing in parentheses. So 2 log base 3 minus log base 6 on both sides. Okay, so when I do that, I'm left with x on one side is greater than or equal to whatever log base 10 of 6 over 2 log 3 minus log 6 is. Okay, now be very careful when you do this on your calculators. You're going to need to use parentheses here to tell your calculator that you want this log base 10 of 6 to divide by this whole piece here. Every calculator is a little bit different about how they want this done, so you need to take some time and make sure that you figure out how to do it on your calculator. But the answer that you should be getting for this, for 4A here, this should come out for you to 4.4190. Okay, you need to make sure, so you need to have a calculator out. Okay, don't skip on this or you're going to be in trouble. You need to make sure that you know how to type this into your calculator in order to get that. Okay, so that's very important. Take some time, pause the video right here and do that. And then go ahead and do 4B on your own. And the next thing we'll do is we'll get to that. So for 4B here, let me just erase what I have done. We'll go to there. Okay, so for 4B, we're going to start the same way as we did before. So we have log 4y is less than log 5 2y plus 1. We're going to pull these things out front, right? So this is y log 4 is less than 2y plus 1. I guess I should put those in parentheses, log of 5. Okay, so then I get y log 4 is less than 2y log 5 plus log 5. Okay, move everything to one side here, so I get y log 4 minus 2y log 5 is less than log 5. Pull a y out, so I have y times log 4 minus 2 log 5. I pulled the y out of both pieces. It's less than log 5. So then y then is less than log 5 over log 4 minus 2 log 5. I just divided both sides by that. Make sure you use parentheses when you're plugging that in your calculator. And when you do this, you should be getting, do it in red here, y value is where y is greater than. Oh, and one thing that we need to consider here, okay, and that I need to pause for a second, is when you evaluate this piece, if this turns negative, if this is a negative answer, okay, then we have to change our inequality because we're dividing by a negative. So you might want to just type that into your calculator, log 4 minus 2 log 5, see if it's negative. If it is, switch the inequality here at the last step, which in this case it is, so I get y is now greater than negative 0.8782. Again, that's negative 0.8782 because it's a little hard to read over there. And that inequality switched. Okay, which that would have been hard to do solo. So no worries if you got that part wrong, if you tried that on your own. Okay, so the key formula for this whole lesson is the change of base formula. The change of base formula is one of the most important formulas for all logarithms. Basically, what it allows us to do is to change any logarithm of any base to base 10. And how I do that is, or to any base for that matter, it doesn't matter, it doesn't have to be base 10, but base 10 is usually where we go because that's the easy thing and that's what's on our calculators. So here we have something like log base 3 of 11, right? So what this allows, this change of base formula allows me to do is you always take the argument that's here and you write that in the numerator, okay, and then the other piece of this is the base. So it's always going to be, you know, it doesn't have to be log base 10, it can be whatever logarithm you want, but log base 10 is usually what we use because that's on our calculators and nice. So log base 10 of 11 comes from this piece divided by log base 10 of 3. So that's called the change of base formula, and very important. It is very, very, very important just to relate everything to a common logarithm of base 10. So here, example 5, the last thing we'll do is they want you to just change this to a common logarithm, and then they want you to round it to the nearest 10th. So on your test and on your homework, I should see you actually writing this out. This is part of your answer. So write it in terms of a common log, then punch it in the calculator, and then give me the decimal. This is going to be log base 10 of 8 divided by log base 10 of 6. And we don't have to write those logs in. We just assume that they're 10 when they're not there. So the other way you could write this is log 8 over log 6, which is equal to, in this particular case, 1.1606. 1.1606 approximately. Okay, and that's all, guys. That's all we have to do here for common logs. I'll have a homework sheet ready for you guys.